Hello everyone, so welcome to this new series on trees. This series of videos will be trying to solve problems related to trees on LeetCode. Especially we'll be looking into binary trees in specific. So in this first video in this series, we'll be learning about some of the basic concepts of tree data structure. So tree data structure is a special type of data structure where the data is stored in hierarchical order. So what we mean by hierarchical order is nothing but it will be in the form of a hierarchy. That is, it will have levels inside it. Like consider this binary tree given here. So here there is a node initially, and that's called the root node. The topmost node of any tree is called as the root node, and below the root node there will be child nodes. So a tree can have as many childs as it wants, but a binary tree can have only at the max of two children. So 28 and 62 are children of the node root node with value 42. So this will be our root node. In this case, a root node is the first parent node in a tree, and following the root node there will be child node, and on the right side there will be right child, and on the left side of the binary tree there will be a left child. So those are the children nodes, and the parent node is the node which is preceding the child node. So for this particular node its parent node would be 42, and for this particular node its parent node would be 42, and for this node the parent node would be 28, and for this node its parent node would be 31. So now let's understand what are subtrees. Since a tree is a hierarchical data structure, so the data structure will keep on repeating at every level. So consider this topmost level, we have two children here, and now if we take this child node as a parent node, then again we have two children, and it's not necessary that it should have only two children. It can have as many child as it wants, but since this is a binary tree, it can have at most two children, or sometimes it won't even have a single child. Then it's called as the leaf node. So a leaf node won't have any child, so here it will be pointing to null, and in Python it will be pointing to none. So that's about the leaf node. A leaf node is the node that's present at the end of the tree. So now to learn about the height of the tree. The height of the tree can be considered as the length from the first node, that's the root, to its leaf node in the tree. So height should be this. This is known as the height of the tree. So the distance from the root node to the bottommost node is known as the height of the tree, and bottommost nodes are usually the leaf nodes. So the height of this tree is 3, since there is a level 1, level 2, level 3, and the topmost level is the level 0. Now to learn about subtrees, since a tree is a recursive data structure, that is it can be solved usually using recursion. So this root node will have two children, that's the right and left child, and so if we take this child as a root node, then this whole structure will again be a tree, right? So again if we take this as a root node, then this whole structure will again be a tree. Similarly, if we take this as a root node, this whole structure will be a tree. So that implies that we can solve tree problems using recursion easily. So now let's learn about the depth of a node. So let's consider this node 59. So the depth of this node would be the distance, that's the height from the root node to the node which we are considering. So here the depth would be 2, since here we have level 1 depth and here we have level 2 depth. So that's the depth of the tree. So subtrees are now looking into in order, pre-order, and post order traversal. So these are very important concepts. So let me erase all this. Okay, now looking into the different traversals. Since trees are recursive data structure, problems can be solved using recursion. So now let's look at some of the traversals which are available in trees. So in order traversal is nothing but first solving the left side of the tree, and then we are looking into the root of the tree, and then we are looking into the right side of the tree. Since it's a recursive method, so this can be applied to every node on the tree. So let's take this particular node. So if we take this node 21, then we can solve the node 17 first through in order, and then we'll look into the node 21, and then we will look into the node 23. Since 17 doesn't have any child below it, so here after printing 17 it will look for 21. So that's the root, and then it will go to the right subtree. Same way for this particular node 62. In order traversal, first it will look for the right subtree, and since right subtree has another leaf nodes, that's the child nodes below it, so the recursion will pass to the child node, and now the recursion will work on the leaf node. Since there are no more nodes in the end, it will go back, and then 52 will be printed, and then it will go into the right subtree, and after that 60 would be printed, and then now both the nodes are covered, so we go back again, and here 62 will be printed. So that's how in-order traversal works. Now looking into the pre-order traversal. In pre-order traversal, the traversal recursive call works like first it will look into the root node. Then it will go to the left subtree. And if no nodes are present, it will go back. If nodes are present, again the same algorithm repeats. So it will again go to the root node. Now since there are no more child here, it will go back. And now after this node, it will go to the right subtree. Same way, once this is covered, then again we go to the right side. Since this entire thing has been covered, so now the algorithm goes to the right side after covering this node. Since this is the root node for the children 67 and 82, first root node will be covered in pre-order, and then we will look into the right subtree. And now right subtree is covered, so it will go to the left subtree. So that's how pre-order traversal works. Now let's look into the post-order traversal. So in post-order traversal, we'll be looking into the root node only at the end. So let's go from the last. So this is the root node. Since there are no more child, we will go back, and then we will look into the right. Since the root node will be considered only in the end, so we will ignore the root and go to the right. After the right has been covered, now we will cover the root node. Similarly, once the left subtree has been covered, now we will look into the right subtree. We will apply the same recursion here. So here it will go to the left, and then to the right, and then we go back to the root. So after the root has been covered, now both the subtrees are covered. Then finally we go to this node. So that's how post order traversal works. Now let's look into breadth first and depth first search. In breadth first search, we will be going from the root till the leaf node. And in depth first search, in depth first search, we'll be going from the root till the leaf node, and in breadth first search, we'll be checking for the breadth of the tree. So the breadth of this particular level is 4, so we'll go in this direction, and we will check for each node 21, 31, 59, and 71, and then we will go to the next level. So that's how breadth first search BFS works. And in depth first search, if we consider this as our root node, so it will go from 62 and then 59 followed by 57. So we are going to till the end. That is we are traversing through the depth from the root to the leaf. Same way we will be traversing through all these directions. So that's how depth first search works. Now let's understand how we can solve a binary tree problem. So there are 3 steps to performing any recursive call on binary tree. So we can solve binary trees using these 3 recursion steps. So first one is to identify our base case. So given any problem on trees, we should first identify the base case. The base case is the case which terminates our recursion call. Otherwise it will lead to an endless loop, right? So in order to stop that loop and bring our recursion to a conclusion, we should have a base case. So the initial base case, let's assume that there is only one node in the tree. Let's assume that there is only one node in the tree, and it's pointing to null, and its children are pointing to null. So now for this tree, how can we write a base case for in-order traversal? Okay, so for in-order traversal, first we'll be looking into the left child, and then we will move to our root, and then we will look into the right child. So that's in-order traversal. So in this case, since there is only one node and its children are pointing to null, first the left subtree call will be done, and on performing the left subtree call, since it's pointing to none, it will return, and then the call will be performed on the root node, and since there is a value in the root node, let's assume there's a list, so this value will be stored here, and there's a call here, and again there's a call here. So since its right child is also pointing to null, so here we will have null and here we will have null. So that would be the in-order traversal of a tree having a single node. Now let's assume the case where we have a tree with two nodes. So in this case, following this same approach, first we will look into the left subtree. Since the left subtree has a node, but that node has 0 children, so both since they are pointing to null, so now the in-order traversal would be like null and then 2 and then n, right? And then we will look into the root, so the root would be 1, and after that, since there are no right subtrees, again it's pointing to null, so the in-order traversal would be 2 1. And now let's assume the case where there are 3 nodes. So let's assume this, there are 3 nodes in the binary tree. So now what we have is that if we perform the call on left subtree, then we have 2, and then we perform the call on right subtree. Before that we will look into the root node, so again root will be 1, and then we'll perform the call on right, so 3. So that's how we will be performing the recursive calls on trees. And as you can see, all the subtrees have the same structure, right? There's a parent and there are two children. There's a parent and there are two children. There's a parent and there are no children. So when there are no children, the function should return. That is, it should go back. So that becomes our base case. When there are no children, we should return this particular value and go back to the previous step. Same way, when there are no children, we should return that value and go back to the previous step. So that becomes our base case for the particular tree. Then after we work towards our base case, things become very easy. So now performing the recursive call is simple. We will be first going to the left child, right? And then we will be looking into the right child. And by child, what we mean here is that all the children below that particular root node. So for this node 62, all of its children will be below it. So on the left subtree we have 3 children, and on the right subtree we have 3 children. So again, if we consider the left subtree, the node 59 will have 2 children. That's the right child and the left child. And same way for node 71 we have 2 children. So that's how we recurse through the tree, and that's how we complete our code for the recursion on the tree. So now let's do a simple problem on tree. We'll just look into how we can perform pre-order traversal in a particular tree. So let's assume that this is our tree. So for this particular tree, 62 becomes our root node, and this becomes our left substructure. That's the left subtree, and this becomes our right subtree. Everything below this will be our right subtree. So for pre-order traversal, let's define pre-order traversal first. So given 3 nodes, first we'll be looking into the root node, and then we will be looking into the left subtree, and then we will be looking into the right subtree. So for this particular tree, now since 62 is the root, we will be looking into the left subtree first, then we will be looking into the right subtree. So the order would be 62, right, followed by the subtree, and then followed by the subtree. So now let's say for the left subtree, so for the left subtree, again 59 becomes the root, right? So we will be inserting 59, and then we'll again go down to the left side, since every time we will be looking into the root, then to the left. So again 57 becomes the root, and since there are no children, we will be returning it. Here we will return simply return it. So 59 followed by 57 and then 60. Now that we have covered our left subtree, we will again look into the right subtree, and here we have 71 followed by 67 and followed by 82. So this becomes the pre-ordered traversal of this particular tree. So that's all about the basic of trees. In the next video, we'll be coding in Python and C++, where we'll be implementing all these problems first, and then we'll be looking into the core concepts of trees, that is medium and hard level tree problems on LeetCode. So thank you. If you like the video, do subscribe and share with your friends.